leaders of the world. Welcome to Spread Love in Organizations, a podcast for purpose-driven healthcare leaders striving to make life better around the world by leading their teams with genuine care, servant leadership, and love. I'm Naji, your host for this special episode in collaboration with MIT Sloan Healthcare and Bioinnovations Conference, an event that brings the healthcare ecosystem together. I have the pleasure to be joined by Collin Stultz, professor in medical engineering and science, professor of electrical engineering and computer science, co-director of the Harvard-MIT program in health sciences and technology, member of the research laboratory of electronics, and associate member of the computer science and artificial intelligence laboratory. Collin is also a practicing cardiologist at the Massachusetts General Hospital, MGH. Collin's scientific contributions have spanned multiple fields, including computational chemistry, biophysics, and machine learning for cardiovascular risk stratification. He is a member of the American Society for Biochemistry and Molecular Biology and the Federation of American Societies for Experimental Biology, and he is a past recipient of a National Science Foundation Career Award and a Burroughs Wellcome Fund Career Award in the Biomedical Sciences. Currently, research in his group is focused on the development of machine learning tools that can guide clinical decision-making. Collin, it's an honor to have you with me today.
Thank you for having me, Naji, and thank you for asking me to participate.
Before we dig in AI as a catalyst for care delivery, which was the topic of your panel at the conference, I'm eager to hear more about your personal story and what's in between the line of such an inspiring journey.
Yeah, thanks. I wish I had a simple way to explain getting to where I am today. It was quite a circuitous route. So I'm an immigrant. I was born in Jamaica, West Indies. We immigrated to this country when I was 4 years old. Parents came from poverty and came here to achieve the American dream. And one of the things I like to, tell people is, like, my parents, religion and education were terribly important to them. So as a youth, the two things that I remember the most was going to church and studying. I was a big nerd. It was a good thing because it kept me away from all of the bad things in the neighborhood that I was surrounded by. Long story short, came to Harvard, loved mathematics, did math and philosophy for an undergraduate major. And my parents wanted me to go to medical school, and I really wasn't keen on it at the time. I wanted to do something in pure mathematics, but pure math really didn't help people the way that a physician could. So I went to medical school, wasn't really fond of that, left for a year, did research, came back, finished up medical school, completed a PhD, and then went on to do an internship and residency. And several years ago, here I am now. So the one thing I can say is what's led me to this point is a bunch of different interests throughout time. And what I have followed more so than anything was what I liked. And it primarily dictated what my next steps were. And the only reason I belabor this point is because I am a little bit of an outlier given the background. I don't come from an academic pedigree. Parents do not come from money. But here I am at Harvard and MIT trying to do things I think that can benefit people long after I pass away, and holding positions that I think my father never would have dreamed. And I think for anybody who's listening from a similar background, such things are possible with a lot of hard work, some tenacity, and a little bit of hubris.
Well, Collin, thank you so much for sharing this. It's so inspiring. Is there one thing that you would give your younger self advice as you were going through this journey that I'm sure, as you said, it's built on hard work, belief? Is there one advice that you would give yourself when you were younger?
Yeah, failure makes you better. And I think that failure is very hard to understand and process in the moment. But after the fact, I think, you realize what you could do better when you fail. And that's really important. So I think we view failure as being a bad thing. It never really is, but it's hard to get anywhere unless you do fail. What's important is learning from when you fail. And if I could have sat myself down and told myself that a long time ago, I think the road might have been a little bit easier.
So now if we go through one of the topics you're fond of and the topic you discussed and led this panel on AI as a catalyst for care delivery. This is obviously, AI is a very hot topic. We hear about it a lot these days. Can you share first your high-level thoughts about artificial intelligence specifically in healthcare? How do you think about that?
Yeah, it's a great question, and I think a lot of this is conflated with what we see on TV, on science fiction shows, what we read in the newspaper. We think about AI as being a series of techniques where you just press a button and then machines and algorithms do things that humans used to do, or that humans can do. And I think in the healthcare, for some things that's probably okay, but for healthcare it's not. I think decisions with respect to one's health are typically done in an informed manner, taking into account the patient's wishes and their value systems, things that are very hard for an algorithm to parse. So the way that I think that AI will function in the future in healthcare is that it's going to provide important information that the healthcare provider can factor into their decision-making. Information that leverages lots of data. So there's, if you look at even the average person's medical record, there's tons of information there, tons. And so you can imagine the scale of information for those who have been ill and have had many interactions with the healthcare system. Healthcare providers don't look at all of those data because we can't, it's too voluminous. But algorithms can. A computer's not limited by large amounts of data, and it can process every piece of data without ignoring even the most minutia or the things that might seem the most irrelevant, and in that way find new relationships and find out new things about patients that we would never have found out otherwise because they're pieces of the data that we don't look at. And so I think that's really the power of AI, being able to uncover hidden truths about patients, hidden facts about patients that are otherwise hard to decipher. And that the healthcare provider, that really is important for the healthcare provider in helping them to discern what's the right actions to take for a particular patient.
So I think you alluded to that. And if we want to go into a more use case specific, how do you see this playing in care delivery specifically? And are you seeing some applications? I know your research is on this, if you can share some of those.
Yeah. So I think one of so I'm going to focus on the thing that I think is the most promising for the future. And it is a lot of care nowadays happens when a patient goes in to see their provider in the hospital, or God forbid, they get admitted to the hospital with an acute illness. And most of the therapies that are prescribed are when you're sitting in front of a healthcare provider and they're using the data right in front of them. How do you look at that point in time? What's your weight? What's your blood pressure? What's your heart rate? And what information they have up until that time in terms of what lab tests have you had with additional studies. But there's so much of life that happens outside of one's precise interaction with the healthcare system in a hospital setting. And can you expand the information that the healthcare provider has to things that are at home? So the information like, how active are you at home? Can you climb up a flight of stairs or not? And can you record someone's activity? How many steps they take throughout a day? Are they symptomatic at home? What's their heart rate at home? What's their blood pressure at home? What's their electrocardiogram? And I think we'll be able to infer a lot of this information in an unobtrusive way in the future with smart devices. So case in point, there is a large, Mayo has done a large study in terms of detecting atrial fibrillation, which is a very common arrhythmia that many patients have. In particular, it's very prevalent in patients with heart failure, and from an Apple Watch. So several 100,000 patients and try to detect when they have this bad arrhythmia from some such easily, you don't have to go into a hospital to get a 12 lead electrocardiogram. You don't have to be examined by anybody. It's just by something on your wrist. And so can we use similar types of data to infer more things? Can we infer things about the cardiovascular health? What's the cardiac output? How much blood is your heart pumping per minute? And that's something that typically you can only get by an invasive procedure, by sticking catheters into the heart itself to make these measurements. What are the pressures inside the heart? And can you use this information to predict, are you going to be admitted to the hospital? What your potassium is, what your lab values are? I think we can get the same sort of information that you would get if you were admitted in a hospital, and we could come close using simple sensors in the outpatient setting. And so we like to refer to this as inpatient information at home, or inpatient monitoring at home. You get the same level of monitoring you would if you were admitted, but it's in a home environment. And I think that's a sweet spot for a lot of these methods.
This is great. And I saw recently Apple actually did get through the study, I think, some approval, right?
Yeah.
Apple Watch.
That's right. Yeah.
So you're bringing this idea of expanding. I love how you framed it, expanding the information that you can get for in-hospital patients outside of home, and really leveraging just to have a more holistic view of the patient when you are treating them and making a decision.
Yeah, that's right. So you could imagine if the patient could be admitted to the hospital every day or come into the hospital every day and get information and titrate medications and make decisions based on that, all from the in-home environment. Because at home, you could get the same information you would as if they were standing in front of you in a hospital or in the clinic.
So as you look into the next decade, right, and more of those connected devices, more data will be analyzed, and ultimately having all our data records in one single place that we can probably use. What is the most exciting advancement in medicine that you think we should all be watching for the next 10 years?
It's a great question, and I am biased, right? Because I am necessarily biased to the things that we're doing in my group. That's the thing that I know most intimately. There are many things that are important, and just to be fair, in a hospital you do a cardiac ultrasound, and it's a very detailed study, just like an ultrasound looks at a baby moving in the mother's abdomen and pelvis. You can get an ultrasound to see how the heart is moving and get a lot of detailed information about the heart function, the valves, and various structures in the heart. And there are data from a number of investigators to suggest that you can get similar information from the type of from these ECG monitors. They are akin to what you get from the Apple Watch, not precisely the Apple Watch or the Fitbit or one of these wearable monitor devices, but from those simple signals, you could get similar types of information that you would get from an ultrasound study. And in our group, what we are working on is sort of the equivalent of digital twins for cardiovascular patients. So for a given patient, what can you infer from the electrocardiogram, other simple signals? What are the pressures inside the chest? What's the cardiac output? All of these things that are normally obtained from an invasive study in a hospital, can you get them at home with just a patch monitor? And can you use this to to do experiments with patients? So what do I mean by that? So if I have two drugs that I think would be good for you to take, I could give you one drug, see how you do, take you off the drug, wash out, give you another one, and see how you do. Now, that's clearly not beneficial, right? Because one of the drugs may have very bad side effects, maybe toxic. But if I had a digital copy of you in the computer, then I could give that drug to one digital copy, the other drug to another digital copy, and follow their trajectories in time to determine who's going to have an adverse event and who's not. And so I can do these, what we call in silico experiments, to come up in a reasoned way the optimal therapy for a patient. And we've been putting a lot of effort into that. And I think for some class of patients, for those certain types of heart failure, I'm very optimistic that we can do quite well in that endeavor. So that's the thing that I'm the most excited about in the pipeline.
This is phenomenal, like having our digital twin, as you call them, to run those experiments instead of actually doing it on us. How far are we from doing that? I know some companies, they have research on, you have your research lab. How far away would I be able to test a drug, as you said?
Yeah, I think a lot of work has been going on to try to make general digital twins. So that's twins for any patient, irrespective of what their diagnosis is, irrespective of what their medical history is. And that's a very, very hard problem. Many different diseases are in the textbooks. And if you're going to try to do this generally, you need a tremendous amount of data, a tremendous amount of high quality data to be able to do this well. And it's our premise that if we can narrow this down to specific groups of interest, so we can do this for patients with a particular type of heart failure. Can we do this for patients with a particular type of diabetes? That we can make, that it lowers the data burden and allows you a better chance of building robust models that can predict patient trajectories, how a patient will do in the future over time in response to different perturbations, different medications, different interventions. So right, it is true there's a lot of work in this space. I think the work that's going on in space, necessarily because of how the problems are posed, are very data hungry, require tremendous amounts of data. Our approach is really a focused one on specific diseases.
So I love that because it's a specific use case where you can gather the data you need and deal with it. So I have two follow-up questions to this. The first one, I'm both physician, I'm in drug development. It is so hard up to now to predict once you get a drug, how you're going to react to it. So I would love to get your thoughts about those in silico, the precision about it. How should you think about it? And probably even getting it into clinical development, actually, instead of participation, but even as a predictor of response, as you said, and side effects that you can get. How do you think about it, again, as science several times humbles us once it gets into human?
No, it's a good question, and the work is ongoing. So the precise answer is still stay tuned. But I will say that I think that all of the information that we have would be their a patient's genetic profile, their transcriptomic profile and the various tissues of interest, their medical history, what they eat every day, right? Where do they live? Unfortunately, what their zip code is. All of these things come in and affect clinical outcomes. And much of this information is encoded in the medical record. Not all of it, but a lot of it. And they're proxies for things like the genetic profile in the medical record. So my sense is that there's a lot of this in both the structured and the unstructured data that we're just not leveraging as much as we can. It's a hypothesis, admittedly, that all of this information is there. But if you can leverage it, it is my view that you have a good chance of being able for important clinical problems. You won't do it for everything. But to give you a specific example, patients with heart failure, a certain type of heart failure called heart failure with reduced ejection fraction, there are 4 different drugs that we like to get all patients on. Not every patient can tolerate all 4 drugs. So for the specific question of patients in this class, can you experiment with these different 4 drugs and see who will tolerate it and who will not ahead of time? And I think the data are there and of sufficient quality to answer directed questions like that. So I think we can make progress, but like most things, it's for the right question. And what's the sweet spot?
I love this. I want to go on the data piece. You obviously everything is based on data, as you said, and the quality of data that there is in. And I can't but think about the biases in the data. So I would love to hear your thoughts about this, specifically on the biases, the lack of data we have on certain ethnicities, on women. You know what I'm talking about. So I'd love to get your thoughts about this.
Yeah, life is very unfair. And medical care unfortunately suffers from some of the same unfairness. As I like to say, all individuals are biased. And I've said this many times before, some people choose to recognize that they're biased and mitigate it, and some people ignore it. And I think so. I think we have to begin from the premise that there is bias in the data. Data are assembled, and we decide what to acquire by individuals who are inherently biased. And that's, again, as I've said on other occasions, that's not a nefarious statement. I think it's just a statement of fact. So realizing there's bias, how do you mitigate it? I think the way that people ordinarily think about this is that they identify groups that have not benefited like that others have. So women in cardiovascular care and in many other areas, people from underserved backgrounds. And you try to say for these algorithms, how do they perform in these groups that are traditionally underrepresented or where these methods do not perform well? And I think that's a necessary thing that we need to do. But the thing that is always in my mind is, what groups are we missing? Because if you come to this with a preconceived notion about specific groups, are you missing groups that you would not have thought of, right? So in the early 1900s, I don't know if anyone would have thought of Black women as being a group that they should focus on. I don't think that would. It's an extreme example, right? And I think things about mitigating bias would have excluded that group. And I just wonder, it's always in the back of my mind about what are we missing that we are not paying attention to because we're blind to. So for me, a part of this is not only coming into this with some prior notion of what groups we tend to be biased against, but trying to discover from the data what groups we are not performant with. What subgroups are we intrinsically biased, and learning about our bias from it. So I think we can try to mitigate the biases that we know might be there, but also try to discover new biases that originally might be blinded to us. And I think both parts of that are important, at least, and it tries to guide our work as well.
This is so powerful, what you said. I always think about what groups are we missing. This is so powerful and so true. I'm going to give you now, Collin, a word, and I would love your first reaction to it. The first one is leadership.
So my first reaction to a leader, a leader is, the first word that comes to mind is follow. Because I think a leader necessarily is a follower. Leadership in part is about listening to others, and in a sense, following, and maybe following is the wrong term, but being sensitive and paying attention to the things that are important to them. So I said following, but maybe what I'm trying to convey is listening. And I think that's an important part of leadership. I don't want to get on a political rant here because it'll get me in trouble. But I will say, in general, politicians, right, widely construed, they're leaders, but but listening is not part of their portfolio. And I say that broadly. And so for me, there are poor examples. Many of them, not all, many of them are poor examples of leadership.
The second one is health equity.
So when I hear health equity, the first one that comes to me is a right. Health equity is a right. I believe it is a right of every individual to have good care that is the same as anybody else's. And that's a terse statement, that's categorical, and that's an easy one.
I certainly do believe in that too. The third one is ChatGPT.
Oh, let's see. What's the word I'm looking? I know what I want to say. It's overrated. Overrated. So I think ChatGPT, for me, the really important thing, it's an example of what some of this technology can do. What can we do with large foundational models, large transformer models, the types of things that they can do? It's overrated in the sense that we often believe what it says to a fault. And in the medical space, there are numerous examples where it is producing data that are incorrect and harmful. So I wish that others would sort of focus this as being an example of the types of things that the technology can do rather than focusing on ChatGPT in and of itself.
So before giving you the final word, I see a picture behind you. So I'm going to give you his name, Einstein.
Yes. Oh, yeah.
And I'd love your reaction to this.
So I love this quote. I'm going to read it. It says, "Great spirits have always encountered violent opposition from mediocre minds." And I am certainly not in the sphere of Einstein by any way, shape, or form. But the sentiment is something that I think is a motivation, motivates me. In that, and I've had a number of famous scholars tell me about the difficulties that they've had in their career when they had a new idea and an inability to get funded and an inability to have people to listen to them, and it took decades later. And they were, my old advisor is the Nobel laureate in chemistry, amongst other very famous engineers here on the MIT campus, I think are examples of that. So that for me is a motivational statement from a mind that was much greater than my own.
The last word is spread love in organizations.
That's very broad. I think I think about doing good things in the world. That's what I think about. And I think that things that aspire us to learn from one another, communicate, and engage in dialogue about new things, technology and otherwise, is only a good thing for us overall.
Engage in dialogue, so important. Any final word of wisdom, Collin, for healthcare leaders around the world?
No. I think I think healthcare people like you and like we dedicate our professional lives to the health of those who are sicker than us, and I think it's a noble profession, and I think as long as we as healthcare professionals keep that at the forefront of our mind, we can never go too astray in doing good.
Well, thank you so much, Collin, again, for being with me today and this great chat.
Thank you so much. And hopefully I'll see you soon in person.
Thank you all for listening to Spread Love in Organizations podcast. More episodes summarizing MIT Sloan Healthcare and Bioinnovation Conference are available on SpreadLoveIO.com and wherever you get your podcast. Follow us to get most recent episodes and spread the word around you to inspire others and amplify this movement our world so desperately needs.